बिस्मिल्लाहिर्रहमानिर्रहीम रब्बी इश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum everyone. My name is Sibga Anwar and I am student of BS Biotechnology. Today I am going to discuss topic of sodium hydrosulfide. So what's the chemistry of sodium hydrosulfide? Another name for sodium hydrosulfide is sodium dithionite. It is a chemical compound with the molecular formula Na2S2O4. It is a reducing agent used in various industrial processes, including water treatment, gas purification, cleaning, and striping. Here we can see the structure of sodium hydrosulfide. The structure of sodium hydrosulfide consists of two sodium ions and a dithionite anion, which is basically S2O4. The dithionite anion contains two sulfur atoms double bonded to two oxygen atoms each, with the sulfur atom also bonded to each other by a single bond. This structure gives sodium hydrosulfide its reducing property as the sulfur atom can readily donate electrons. The next one is structure and properties of sodium hydrosulfide. The structure of sodium dithionite or sodium hydrosulfide has been examined by Raman spectroscopy and single crystal X-ray diffraction. Sodium hydrosulfide is a reducing agent with a potential of 0.66 volt at pH 7 compared to the normal hydrogen electrode. It reacts with oxygen and water to form bisulfite, thisulfite, and sulfur dioxide. Sodium hydrosulfide has some key properties. The first one is that it is reducing agent because it can readily donate electron, which are making it a powerful reducing agent in various chemical reactions. Due to its solubility in water, which facilitates its use in various aqueous solutions. Sodium hydrosulfide is effective in bleaching textile, paper pulp, and other materials by reducing colorants and chromophores. Its reducing ability can be influenced by temperature, with higher temperature generally enhanced its activity. Now we can see that the preparation of sodium hydrosulfide, that how to prepare sodium hydrosulfide. Sodium dithionite is industrially produced by the reduction of sulfur dioxide. In this step, it involves in two steps. In the first step, two atoms of sulfur dioxide react with zinc, which forms zinc hydrosulfide. In the second step, zinc hydrosulfide react with two atoms of sodium hydroxide or sodium carbonate, which form sodium hydrosulfide. Here we can see sodium hydrosulfide in powder form, which is basically white, and it is dry. Now we are going to discuss the uses of sodium hydrosulfide. How sodium hydrosulfide is used in water treatment. Sodium hydrosulfide is used in water treatment processes such as bleaching and disinfecting. The second one is gas purification. To remove impurities, sodium hydrosulfide is used in gas purification. The next is cleaning. Sodium hydrosulfide is used in cleaning processes to remove stains and corrosions. Like in our home detergents, sodium hydrosulfide is used to remove the stains and corrosions. The next one is striping. For removing coatings and finishes, we use sodium hydrosulfide in striping processes. How we can use sodium hydrosulfide in food industry? Sodium hydrosulfide is also used as a bleaching agent and preservative in foods like dried fruit, vegetable, and sweets. The next one is textile industry. Sodium hydrosulfide is used in textile for dyeing and finishing processes such as indigo dyeing and color removal. As we know that sodium hydrosulfide is a reducing agent, so now we learned that how sodium hydrosulfide work are used as a reducing agent. Sodium hydrosulfide function as a reducing agent by donating electron to other compounds, thereby reducing their oxidation state. This property allows it to chemically reduce other components such as oxidizing agents and is the basis for its various industrial applications. Sodium hydrosulfide as a reducing agent for iron stain removal in organic and inorganic substances and to treat corrosion in copper and silver objects. Sodium hydrosulfide as a reducing agent by donating its electron to other compounds. In this process, it undergoes oxidation itself, transferring electron to the substance being reduced. This ability makes it useful in a variety of different applications. Sodium hydrosulfide is stable when dry and in white powder form, but decomposed in hot water and acidic solution. It is produced industrially by reduction of sulfur dioxide. Aqueous solution cannot be stored for long due to hydrolysis. Basically, sodium hydrosulfide role as a reducing agent which is essential in various industrial processes and chemical reactions where the reaction of other substances is required. Reduction of other substances is required. Now we can see that manufacturing of sodium hydrosulfide. Sodium hydrosulfide or sodium dithionite is manufactured commercially through several processes. Some most common methods are given below. The first one is through zinc dust process. In zinc dust process, sulfur dioxide reacts with zinc dust to form zinc hydrosulfide. Then zinc hydrosulfide is then treated with sodium hydroxide or sodium carbonate to produce sodium hydrosulfide. Through amalgam process, in amalgam process, sodium bisulfite and sulfur dioxide are reduced with sodium amalgam to obtain sodium hydrosulfide. Through formate process, sodium bisulfite and sulfur dioxide are reduced with formic acid and sodium formate to produce sodium hydrosulfide. The last one is through sodium hydride process. Gaseous sulfur dioxide is reacted with solid powdered sodium hydride at 50 to 100 degrees Celsius to form an unstable addition compound. The addition compound is converted to sodium hydrosulfide, which is dehydrated by dissolving in water and crystallizing. Here I am written some key points to understand the manufacturing of sodium hydrosulfide clearly and easily. First of all, we have to generate sulfur dioxide gas, then react sulfur dioxide gas with a reducing agent. Any reducing agent can be used, zinc dust, sodium hydride, etc. Then treating the resulting compound with sodium hydroxide or sodium carbonate, from which we crystallizing and drying the sodium hydrosulfide product. We can see sodium hydrosulfide in its storage form. Sodium hydrosulfide is also used for dechlorination. In dechlorination, it is employed in water treatment to remove excess chlorine from water, which is crucial for maintaining safe drinking water and preventing damage to plumbing system. Next, here are some industrial application of sodium hydrosulfide. As we know that sodium hydrosulfite has a wide range of industrial applications due to its strong reducing properties. Here are some industrial applications are included. The first one is textile industry. Sodium hydrosulfite is used for reducing dyeing, reduction, cleaning, printing, and decolorization for silk, wool, nylon, and other fabrics. It is used as a bleaching agent for textiles. It can remove color impurities and whiten fabrics without damaging them. It is particularly effective for ward dyes and does not contain heavy metals, resulting in bright and non-fading colors. Paper and pulp industry. Sodium hydrosulfite is used as a bleaching agent for wood pulp and paper, ensuring whiteness and brightness without damaging fibers. Sodium hydrosulfite is employed in the bleaching of wood pulp to produce white paper products. Food and beverage industry. Sodium hydrosulfite is used for bleaching foodstuffs such as gelatin, sucrose, honey, and candied fruit, as well as for cleaning and bleaching animal and plant oils, bamboo, and porcelain clay. In organic synthesis, sodium hydrosulfide serve as a reducing agent. Various chemical reactions such as the reduction of carbonyl compounds to alcohol and in the production of dyes, pharmaceuticals. In water treatment and gas purification, sodium hydrosulfide is used to remove impurities and contaminants from water and gas streams, ensuring their quality and safety. Leather and polymers. Sodium hydrosulfide is used in the tanning and processing of leather as well as in the production of various polymers. In the production of photographic films, sodium hydrosulfide is used and as a reducing agent in printing processes. The next one is chemical enhanced oil recovery. Sodium hydrosulfide helps stabilize polyacrylamide polymers against radical degradation in the presence of iron, enhancing oil recovery. In soil chemistry, sodium hydrosulfide is used to determine the iron content in soil chemistry. Other applications In other applications, sodium hydrosulfide is used in various other processes except of yeah, or other than of industrial applications which are including cleaning for hair treatment and metal recovery. Sodium hydrosulfide also used for dechlorination of water in municipal water treatment plants, reduction of aldehydes and ketones to alcohol in organic synthesis, preservation of food products by preventing color changes and oxidation, bleaching of cotton fabrics in textile industry processes. In the picture we can see that in fiber bleaching, as I have already told, that in fiber bleaching, sodium hydrosulfide is used for removing all the stains and corrosions, and it is basically in textile industry process. In food bleaching, sodium hydrosulfide also used for the preservation of food, as I had already discussed above, and it is also used in silk wool bleaching and in watching bleachings, etc. In all these peaks and industries, sodium hydrosulfide is used as a reducing agent and providing whitening. Now, as we know that all the chemicals, if not properly stored, they all have hazards, potential hazards. So, here are some potential hazards if sodium hydrosulfide is not stored properly. If sodium hydrosulfide is not stored properly, it can pose several hazards. The first one is self-ignition. As sodium hydrosulfide has flammable nature, so it can self-ignite and catch fire. In self-ignition, sodium hydrosulfide is sensitive to moisture and can decompose in the presence of water. This decomposition can release heat as a byproduct, due to which it can catch fire and self-ignite. Sodium hydrosulfide, when stored in large quantity or in poorly ventilated areas, the heat generated from its decomposition reactions which may not dissipate efficiently. As a result, the temperature of the material can increase, which can also catch fire, due to which and can self-ignite. The next one is harmful if swallowed. Ingestion of sodium hydrosulfide can be harmful if it's swallowed. It can cause irritation of the gastrointestinal tract, leading to symptoms such as nausea, vomiting, abdominal pain, and diarrhea. In several cases or with large doses, it can cause some serious health effects, including systematic toxicity and damage to internal organs. If someone swallows sodium hydrosulfide, it's important to seek medical attention immediately. They should not induce vomiting unless instructed to do so by a healthcare professional. Instead, they should rinse their mouth and drink plenty of water to help dilute the chemical and minimize its effect on the digestive system. The next one is serious eye irritation. Sodium hydrosulfide can cause serious eye irritation if it comes in contact with the eyes. Exposure to sodium hydrosulfide dust, vapors, or solutions can result in irritation, redness, tearing, and potentially more severe damage to the eyes. If sodium hydrosulfide gets into the eye, it's crucial to flush the eye immediately with lukewarm water for at least 15 minutes while holding the eyelids open to ensure thorough rinsing. Medical attention should be sought promptly, especially if irritation persists or if there are signs of injury into the eyes. To prevent eye irritation, it's important to handle sodium hydrosulfide with care. Wear appropriate protective equipment such as safety gloves, face shield when working with it, and avoid splashes or direct contact with the eyes. Harmful to aquatic life. Sodium hydrosulfide is toxic to aquatic life and can cause long lasting effects. Sodium hydrosulfide can act as a reducing agent, potentially affecting the oxidation reduction balance in aquatic ecosystems. This disturbance in the balance of chemicals and nutrients can disrupt the normal functioning of aquatic organisms and ecosystems. To minimize the risk of harm to aquatic life, it's important to handle and dispose of sodium hydrosulfide properly. Following applicable regulations and guidelines, spills should be promptly contained and cleaned up to prevent the chemical from entering waterways. Additionally, wastewater containing sodium hydrosulfide should be treated before discharge to minimize its impact on aquatic environment. The next one is moisture sensitivity. Sodium hydrosulfide is sensitive to moisture and can decompose or react with water, leading to hazardous conditions. When it exposed to moisture, it can undergo decomposition reaction, releasing heat and potentially leading to the formation of hazardous byproducts. Moisture can accelerate the decomposition of sodium hydrosulfide, reducing its stability and shelf life. To prevent moisture sensitivity issues with sodium hydrosulfide, it should be stored in a cool, dry environment in tightly sealed containers. Proper handling practices should be followed to minimize exposure to moisture during storage, transportation, and use. Additionally, precautions should be taken to prevent the ingress of water or humidity into containers of sodium hydrosulfide, as even small amount of moisture can trigger decomposition reactions. The next one we have reactivity with incompatible material. Sodium hydrosulfide can react with strong oxidizing agent acid and other incompatible material, causing hazardous reactions. Strong acid we have through strong acid, sodium hydrosulfide can react voluntarily with strong acid, leading to the release of heat, flammable gases, and potentially causing explosions. The next one is fire and explosion risk. Sodium hydrosulfide can ignite and explode when in contact with oxidizing agent or when exposed to excess heat. In excess heat, there is flammability. While sodium hydrosulfide itself is not flammable, it can react with incompatible materials such as oxidizing agents, strong acid or metal salt to generate heat, flammable gases, or even ignite spontaneously under extreme conditions. In spontaneous combustion, in the presence of moisture, sodium hydrosulfide can decompose, releasing heat. If the heat generated is not adequately dissipated, it can lead to a rise in temperature and potential self-ignition and potential rise in temperature or spontaneous combustion. To minimize the risk of sodium hydrosulfide with risk of fire and explosion, store sodium hydrosulfide away from heat sources, open flame, and sources of ignition. Keep sodium hydrosulfide containers tightly sealed to prevent exposure to a moisture. Avoid contact with incompatible material and ensure proper segregation and storage practices. Handle and use sodium hydrosulfide in accordance with safety guidelines and procedures, including appropriate personal protective equipment and ventilation measures. In case of fire or explosion, follow emergency response procedures and evacuate the area immediately while not notifying emergency services. Here are some safety precautions. The first one is handling. While using any chemical, we have to handle it with care to avoid from dust formation and splashing. Storage. Store in a dry place, tightly closed and away from heat sources, moisture and air. Every chemical should be stored like this. Incompatible material. Avoid mixing with incompatible substances or materials that can react with it. Here the next are given personal protective equipment. Before using every chemical, we have to personal protection. For personal protection, we have to use or wear gloves, goggles, and a self-contained breathing apparatus if handling in a confined space or if there is a risk of inhalation. So, personal protection is compulsory and prior. Emergency procedures. Follow standard emergency procedure for handling chemicals, including fire extinguishing and spill cleanup. Avoid eating, drinking, or smoking while using any chemical. So we must have avoid eating, drinking, or smoking when handling sodium hydrosulfide. The next one is avoid formation of dust and aerosols. Avoid forming dust and aerosols during handling and storage. Before using every chemical, we have to learn first of all its guidelines and use in a laboratory instructor, and then we have to use any other chemical. Here I have given a pic of sodium hydrosulfide, and its conclusion or summary of sodium hydrosulfide is that it is a versatile chemical compound with a various industrial application. As being a powerful reducing agent, it is widely used in textile bleaching, paper manufacturing, water treatment, organic synthesis, and food processing, as we already discussed about. However, sodium hydrosulfide poses certain risks including toxicity if ingested, serious eye irritation, harmful effects on aquatic life, moisture sensitivity leading to the decomposition, and fire and explosion hazards under certain conditions. Therefore, proper handling, storage, and disposal practices are essential to ensure safety and mitigate potential risks associated with its use. Despite its hazards, sodium hydrosulfide plays a crucial role in numerous industrial processes, contribute to the production of a wide range of products essential for daily life. Always remember to wash your hands thoroughly after handling any chemical, even if you have been wearing gloves. Before the disposal, let's make sure to follow the appropriate waste disposal guidelines for this chemical to minimize environmental impact. Prioritizing safety ensures not only personal well-being but also the well-being of those around you, the environment and the environment.